Okay, today's lesson is going to be on the order of operations. The objective today is always an I can statement, and the I can statement today is I can simplify expressions using the order of operations. Okay, I'm going to go ahead and flip to a blank screen here. Okay, for order of operations, please write vertically this PEMDAS. You probably heard the acronym PEMDAS. We use this to help us remember which steps we should take. P stands for parentheses. E stands for exponents. M and D, you'll notice I don't write them vertically because one isn't more important than the other. M and D stands for multiply and divide. And I always do that from left to right. And then you'll notice AS is also the same. So A stands for addition or add. S stands for subtract. And we also do that from left to right. Okay, I'm going to copy this and I'll refer back to it for each one of our examples. And I'm going to go ahead and flip to a new screen. Okay, for example 1, my problem is 3 minus 12 divided by, in a set of parentheses, 3 plus 3. I'm not a big fan of that division symbol, but we'll use it for this problem. Okay, you'll notice I have my order of operations kind of shrunk down over here in the upper right hand corner so we can refer to it. You'll have it in your notebook so you can just see it. So I just start looking through the problem. P, parentheses. You'll notice I'm going to use some braces. I see a set of parentheses. I go ahead and add those together. 3 plus 3 is 6. The parentheses go away, and everything else just drops straight down. Okay. I go down to the next step. No more parentheses. E, exponents. I see no exponents, so I can skip that step. Next one, M and D, multiply and divide. I see right here that I have some division. And you'll notice how I included that negative with the 12, because those two are linked together. When I divide negative 12 divided by 6, I get negative 2. The 3 drops down. And then the last step, add and subtract, I see 3 minus 2. And my final answer is 1. And get in the habit of putting a box or circling your final answer so you can find it easier later. Okay, I'm going to go ahead and flip to a new screen. Okay, example 2 is 4 plus 2 cubed, or we say 2 to the third power, divided by 2. Okay, going through my problem. P, I see no parentheses. I can skip it. E, exponents. I do see exponents right here. Positive 2 cubed. And I do want to put a little side note down here. I'll do this in orange. 2 cubed is equivalent to 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this would turn into a positive 8. The 4 drops down, divided by 2. And then I continue through my order of operations. I'm down to the third step, M and D. I do see some division. 8 divided by 2 is 4, positive 4. And then the last step, A and S, add and subtract. 4 plus 4 is 8. And I put a box around it so I can find it easily later. Okay, new screen. Okay, before I move on to the next few examples here, I'd like you to write down the statement above, combine like terms. This is some new notes. And basically the way these work, to keep it as simple as possible, is if terms look alike, I can add or subtract them. Okay, and this will make sense when we start going through the problem. Example 3. Okay, the problem looks like this. 4 minus 3m plus m minus 6. Okay, when I use the word terms, I'm talking about, for example, this 4 is a term, this negative 3m is a term, this positive m is a term, and this negative 6 is a term. Okay, terms are numbers, or they're variables, or the combination of the two. And you'll notice, since there's 4 different terms, what's separating them is the addition and subtraction. Okay? Okay, I'm going to go ahead and get rid of that. Okay, one thing I'd like you to do is, you'll notice this m here that's all by itself. I want you to get in the habit of just putting a 1 there. You don't always see this in math, but we just have to know it exists there. So when we're first doing these type of problems, just kind of get in the habit. Okay, combining like terms is pretty easy. I'm going to go ahead and put a geometric shape around the terms that are identical. So you'll notice I've got a negative 3m and I've got a positive 1m. And you'll notice I include the sign with them because the negative is linked to that 3m. Now when I put these two terms together, I'm adding or subtracting. Negative 3m plus 1m combines to negative 2m. Okay, and likewise, you'll notice I also have this, I put a circle around this negative 6 and this positive 4. They also are like terms. Neither of them has an m, so I can combine those. And 4 minus 6 is negative 2. And at this point, this is my final answer. I'll go ahead and put a blue box around it. I cannot put them together because one has an m and one does not. And that's as simplified as I can get this specific expression. Okay, I'm going to flip to a new screen. Okay, example 4 is x minus 6 minus 7x. Okay, so you'll notice I have 3 terms this time. There's a term, there's a term, there's a term. Separated by the subtraction. Okay, I am going to go ahead and put a square. Well, I want to start off by putting a 1 here, get in that habit. I'm going to put an orange square around all the terms that contain an x. And you'll notice this guy is kind of by himself, so there's nothing I can do with him. So I do 1x minus 7x is negative 6x. And this negative 6 just drops down. And that's just coincidental that these are both negative 6 and the last ones were both negative 2's. I'll try to make that not happen next time. And there's my final answer. Okay, I'm going to go ahead and flip to a new screen. Okay, example 5. Example 5 looks like this. 5 parentheses 2n minus 4. Okay, this one's a little bit different than the last two. I'm going through my order of operations. My parentheses. The problem I have with this set of parentheses is I cannot combine these. One has an n, one does not. They are not like terms. Okay? What I would like you to do is circle the 5 and draw 2 arrows for me. Okay, and over here I'm going to put a little side note. We call this distributing. I'm going to say distribute. Okay, when I'm distributing, I'm just multiplying twice. 5 times 2n is 10n. 5 times negative 4 is negative 20. And that's as far down and simplified as I can get. Okay, one more example. I'm going to flip to a new screen. Okay, example 6 is going to be kind of a combination of everything. Let's start out by making it negative 7n plus 10 parentheses 2n minus 3, go ahead and close your parentheses, plus 5. Okay, so I start going through my order of operations. Again, I'm having trouble with these parentheses because they're not like terms. I cannot combine them. So I'm going to go ahead and circle this positive 10, and I'm going to distribute. I'm going to multiply 10 by everything, both those terms, inside that set of parentheses. Okay? 10 times 2n is 20n. 10 times negative 3 is negative 30. And then I'm just going to drop this other stuff straight down. Plus 5. I've got a negative 7n here. I do have to indicate this 20 as a positive to separate those two terms. Okay, now I have some things that look alike. So going through the order of operations, no parentheses, no exponents, technically no multiply and divide, and now I'm down to add and subtract. I need to combine like terms. This has an n, this has an n. This has no variable, and the positive 5 has no variable. So I can put these two things together, I can put these two things together. Negative 7n plus 20n is 13n, and negative 30 plus 5 is negative 25. And that's my final answer.